This video will explain how a civil war was prevented through risk theory. A fictitious event from a superhero movie is used where it is discussed which superheroes win, but what was needed by whom and how the expenses incurred and the total costs are covered. In this hypothetical case where one part is paid by the superheroes and another by the city. First, Iron Man is supposed to pay up to $350 billion. After this amount from 1,000 Batman, and the city of a billion on wars that represent the excess. To determine the following costs and expenses, the right model is used, which is a model of collective risk. Here, first the severity is represented by the random variable x sub I of the cost in billions of dollars caused by the superheroes depending on the claim I. The frequency, that is the random variable of the number of claims, is represented by n. The aggregate loss is determined by random variable s equal to x sub 1 plus x sub 2 up to x sub n. Then n is a random variable, and in this case, the central limit theorem cannot be warranted to work. So we use the fault probability theorem to find the distribution of the claims. Well, in this case, we determine the severity with a gamma distribution with alpha shape parameter equal to 18 and theta scale parameter equal to 6 for the variable x sub I, and the frequency with a Poisson distribution with lambda equal to 7 for the variable n.
For the Excel for gamma distribution of stability with x distributed as a gamma, we have that B alpha is equal to 18, theta is equal to 6, and therefore the expectation of x is equal to 108, and this is the alpha multiplied by theta. So lambda is equal to 7, and this is also the expectation. Now let's get with a problem. And so here is our probability, that is 0 claims, is this number right here, that is 0.00091188, and this is using the Poisson distribution using this function in Excel. So we have to do this until we reach 1. So as we can see here, if we do this 28 times, here we have that the cumulative distribution, we reach number 1. So 28 is enough data. Now let's consider the amount of claims will be up to 1,000, sorry. And well, we do this until this data right here. That must be enough to solve our problem. So now let's calculate the proof of have 0 in amount in 0 claims. For that, we have to use gamma distribution, and here first we have our probability, then we have our alpha, and here we have to do a little trick, that is multiply the alpha with the n, and then put the theta, and then put that 0 because what is known as the null probability for Excel. So we do this, and we can see our result, our table, and we also do that for all the columns and piles. And we do this procedure for all the amounts and the necessary claims.
We have to see now that each row and the column in its accumulated sum is equal to 1, and each line, the sum, will also be 1. Now, we are going to calculate the probability that S is equal to S small. In this case, we are going to apply the sum product function between the Poisson probability mass and the gamma probability mass, and that result, we drag it to all the rows. Now, we calculate the expectation of S in 3 different ways. The first would be with the formula that the expectation of S is equal to the expectation of N multiplied by the expectation of X. Now, we are going to verify this result of the expectation of S with 2 other different formulas. In this case, it would be through the formula of the sum product of the column, where we have just obtained the probabilities that S are equal to S small, and the column that show us what the value of that S is. And in the end, it gives us the same result with any of the 3.
Now we're going to talk about the expenses of Iron Man, Batman, and the city, and all the payouts that these 3 have to do. We need to know that Iron Man decides to cover the expenses for the first $350 billion. Batman agrees to cover damages from $350 billion to $1 trillion, and the rest will be covered by the city. Now we know that the limit of Iron Man, so we define this function to establish the amount that Iron Man have to pay, knowing the limit that is $350 billion. Well, now we calculate the expectancy from Iron Man, and we have this that is $343 billion. And well, this represents the total amount that Iron Man have to pay. And we have to calculate this probability, and we calculate it by this function called summa, and we took the values where the severity is greater than the premium, which is 343. Well, that means a probability of 93%, and this means that Iron Man have a probability of 93% that he will end up paying more than $350 and $43 billion. If we took the complement of this probability, is almost 7%, and this probability means that Iron Man will not have to pay it, and this means that he will not buy the insurance. Then we have Batman, that we need to do define the same function C, but to define the payout. And the expectancy of Batman is 374, and that is the premium that he has to pay. and the probability is 51%, and this means that he have this probability of almost, well, more than 50% of losing more than $374 billion, which means that he will prefer give that money than and not take a risk to this number to be even more. And well, this happened because he has a limit that is greater than Iron Man, and which means that he has a lot to lose. And well, he will take the insurance. Finally, the city, we have a premium of only $37 billion, and the probability that the city will end up paying more than this is 60.8%. And well, this is what the city is going to end up paying, and the city will take the insurance. And well, if we calculate, we can sum the 3 premium of each of one of these, and we have a result of 756. And well, this is the same result that we calculate before, but in this one we develop all the expenses of the 3 parts involved in this situation, and we conclude that Iron Man will not take the insurance, while Batman and the city will take the insurance.